So good evening, everyone. Hello.
Good evening, sir.
Yeah,
A
this
very
is
good
Mayur.
evening.
Yeah.
Yeah, good evening, sir.
So
Good
why
evening, sir.
very few people are there? Only 18 are there. Why?
Because there is also a city session from
Oh,
4
city
to 6.
session. Yeah. Okay. Okay. Is it's not finished yet? Huh? Okay. Fine. Okay. So today is week 10 open session. So what do you think? Like what we should do? Like shall I do some uh, you know summary of the week 10, or all of you have gone through all the lectures in week 10?
So summary, if you
Yeah,
review
Sambi.
the concept,
Okay.
after that we will ask question.
Okay. So all of you, so any of you have gone through lectures, or you- nobody has
Yes,
done?
sir.
Okay. Have you tried solving activity questions?
Yes,
No,
sir.
sir.
No. Yes. Yes or no?
Yes, sir. Done, sir. All the.
All. Okay. Fine. So okay, I'll do a brief summary of week 10. And before starting, since week 10 is expectation and variance of a random variable, so you need to know what is random variable. Okay. So I'll just start with that first. Maybe all of you know what is random variable, how to compute the probabilities using the random variable. I will slowly start with the random variable, and then we'll go into expectation and variance of a random variable. Then we'll see some properties of expectation and variance. So okay, first of all, what is expectation? Do you know that? What is expectation? What is okay, first of all, what is expectation?
Sir, expectation.
Huh? Yes, what is expectation? Expectation of anything.
Sir, which we assume that will happen.
Oh, what is it? What is the definition? What is usually assumed that it will happen? What is it? Expectation is in general. So my screen is not visible to you, right?
Yes, sir.
No, sir.
Okay, fine. So let's see this one. Okay. Generally, what is expectation? It's kind of an average, right? You can think it as of average, but
Long-term
long
average,
term average of, yes.
yeah,
So
of an event.
right, right. So first of all, what is event? What is an experiment? We'll start. Try. We will try to understand these things first. So let's say what. Okay. In general, how do you find the probability of tossing a coin? So let's say I have, okay. Maybe I'll write it down. So I tossed a coin once. Right. Say I tossed a coin once. And this, let's say this is unbiased coin, right? So if I tossed a coin once, what will be the outcome of this
One
tossing
by
a coin?
two, one
No,
by two,
outcome
one by two.
outcome of this.
Oh,
Okay,
Outcome can be a head or
head or tail.
head or tail, right? So
Yeah.
let's say I tossed a coin. So tossing a coin is what? It's an experiment, right? Or I can say a trial. Maybe I can say a trial, or maybe I'll say that it is an experiment, right? Okay. The
yes,
outcomes of these two trial is what? Or
head
one,
and
this
tail.
experiment is what? Head or tail.
Head
So
and tail.
if I toss a coin, I'll get either a head or a tail, right? And then I'm saying that this is an unbiased coin. What does that mean? Unbiased coin, that means,
Equal chances of both the
yeah, so
outcome.
equal chances. So equal chance
Probability
means
of
what?
getting head
Yeah,
and tail are same.
right. So probability of getting head, I'll write this as, so
Half and
getting
half.
half, right? And probability of getting a tail is half. Okay, or
Half.
0.5, right? But what is getting a head? Getting a head means what? Is it's what?
Chances of
So
getting ahead.
yeah, that is fine. No, no, no. Generally, this is an event, right? Getting a head is an event, right? So if this is my experiment, right? What is the sample space of this experiment?
For
Head,
head and tail.
head and tail is a
You, sir.
sample space, right? No, that is number of elements of a sample space, right? Or I can say,
So
okay, if this is a
Yes, sir.
set, then what do you call to that the number of elements in a set? I'm okay, I forgot the name, but okay. So
Cardinality.
cardinality of this space, right, or the sample space, right? So this is sample space, right? This sample space, and I have two outcomes, head and tail. So I said that okay, this is a sample space, and I said that I wanted to. So I defined an event such that okay. So my event is let's say I define an event A such that I get a head, okay? Such that I'll get a head. What does that mean? What is an event? Event A represents what? Or okay, what is uh, okay? This is the outcome, right? Or this is an event, right? A is an event. I'm saying that I'll get a head, right? Okay. So probability of A is what now? If this is an unbiased point, in that case, this is 1 by 2, right? Another event, if I define that getting a tail, right? What is the probability of associated with that event? Probability of B. It's again 1 by 2. Okay. So this is the general scenario, right? If I wanted to define a random variable, so if I okay, now I'll start with the random variable. Let's say if I wanted to define a random variable x such that define a random variable such that I'll get a head. Okay. Okay. So in this case, so x is my random variable. Okay. So what do you think? And I define that number of heads coming or or getting a head. If I'm saying x is a random variable which is defined as getting a head in a toss, right? In one toss. So right. So what values x will take? So okay, what does
zero
that
and
mean? Yeah, what does that mean? Zero. Zero means no head, right?
zero
No
means
head.
tail will come. No head.
And one means what?
One head.
One
It will
head.
be one head or one head or yeah, only head. Just success
Head.
and probability, right? Currently, or success and failure. So zero means I'll define this as failure, and getting a head means I define this as a success. Currently, this is scenario, right? So I can represent this by -1 also, right? Right? -1. I can define. Okay, I say I represent -1 as getting no head, and I represent 1 as getting a head. But generally, what we do is we'll say that 0. Right? 0 is what? No head, and 1 is head. So what is the probability that x is equals to 0?
100.
Probability of x equals to 0. So x equals to 0 represents what here? No head, right?
1
No
by
head
2.
means what? No head means getting a tail,
Tail.
right? And the probability associated with it is 1 by 2. Okay. Similarly, probability of x equals to 1 is what? 1 by 2. What it represents? X equals to 1. That means one head, right? Okay. Or head. I'll say head. Getting a head, right? That is and the probability associated with that x equals to 1 is 1 by 2. So if I wanted to draw a probability, okay. And what is the probability of this thing is if I uh, pro- yeah, if I take a sum of these probabilities, it will be equals to 1, right?
One.
So probability that x equals to 0, that is no head, plus probability that x equals to 1 is equals to 1, right? What are you
Yes.
seeing here? So these are the two events, right? These are the two events. So probabilities of uh, all events, right? That is equals to 1 here, right? So if I draw a table here, So x will take two values, 0 and 1, suppose. Okay, and is the probability of x associated with it. One. Okay, say like this, right? This probability of x equals to small x. Small x is what? Either it can be 0 or it can be 1, right? That is the values taken by that random variable. So what are the values taken by random variable? 0 and 1,
One
right?
by two.
Yeah,
0
0 and 1. So if I say x equals to x,
Yes, sir.
means x can take either 1 or 1 here. So this will be the probability distribution, right? Probability distribution of the random variable, or I can say, yeah, this is the probability distribution, right? Okay. So this is for one case, right? This is for one case, which is tossing a coin. Generally this distribution is belonging to what? Bernoulli distribution. We will come up, like, I don't know you guys have seen this before or not, but this is generally a case of Bernoulli distribution, and this is a probability distribution of a Bernoulli random variable. Okay, but this is a general scenario in case of a random variable. So I'll take one more example. You guys tell me how to define the random variables for that case. So suppose my experiment is now, let's say, rolling a die. Okay, unbiased die, or I'll say fair die. Rolling a fair die once. Okay, so and this is a six-sided die. Okay, six-sided die means what? We have six faces to that dice, right? And so okay, what will be the outcome in this case?
1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, and 6. These are the outcomes of the, and this is the sample space of this experiment also, right? So 1, 2, 3, 4, 5, and 6. These are, and since uh, this six, so since I said that this is a fair die, what are the probabilities associated with each of this number?
1
Will
by
be
6.
1/6, 1/6.
1 by 6, right? This is uniform, right? This uniform discrete distribution, right? Because each of these outcomes will is having a same probability. So this is uniform distribution, and discrete uniform distribution, right? Okay. Okay, what kind of events I can actually define it from here? Or let's say I define a random variable x such that
Getting an even number.
okay, let's say x is a random variable which says getting a even number. Okay, this is one of the, okay, let's say, okay, what do you think? Okay, previous case I said getting ahead, and I say this x equals to 0 and x equals to 1, these two values, it is taken by the random variable, and that is what, this is the range of random variable, right? Right.
I- In this case, it becomes 2, 4, 6.
So getting a even number. So what are the even numbers here? Is 2,
2, 4, 6.
4, and 6. These are
6.
the even numbers,
And
right?
even
Okay.
number.
Okay. So first of all, can you tell me what values I should represent this? So x will take what, and x, which values I can represent?
2, 4, 6.
2, 4, 6.
2,
Yes,
4,
sir.
6, or anything else? 0, 1.
0, 2, 4, 6.
0 is not here, no?
Why, sir?
Where is 0? So this is an experiment, rolling a fair die, right? So the outcomes are 1, 2, 3, 4, 5, 6, right?
1 to 6.
So getting an even number means what? Which are the even numbers? 2, 4, and 6. But
6.
this is not a value taken by a random variable, right? Generally the values taken by a random variable will be defined by you only, right? Okay, so let's say x equals to 0 means what? If I represent x equals to 0 as no even number,
Not getting an even number.
right? and x equals to 1 is at
Getting an even number.
even number, right? Okay, so now tell me how this probability distribution will look like.
For probability distribution of x equals to 0 will be 1 by 2 and x equals to 1 will be 1 by 2.
Why this is like this? Why this
Because
distribution look like this?
uh, number of even number will be 1 by 6 plus 1 by 6 plus 1 by 6, which is will
3
be
by
1 by
6
2.
and 3
Even
by
and
Right,
odd are
so
equal numbers.
yeah, no even number means getting an odd number.
odd
Okay,
number.
in that case the probability will be probability that x equals to 0
Sir,
is equals to
why?
what?
So why you are taking only 0 and 1 value?
Because okay, tell me, okay, what values it should be taken, can you tell me first?
2, 4, 6,
Okay, if I write x equals to 2, 4 and 6, then what
6.
are the probabilities associated with it?
1 by 6, 1 by 6, 1 by 6.
Like this you are saying, right? Okay,
Yes, sir.
It will be
what
not
do you
a
understand
probability.
from the this random variable? So what are the properties of this probability distribution actually? Your some
Greater
of the,
than
yeah, okay,
sum is equal to 1 and greater than equal to 0.
right. So each of the probability should be greater than
Yes, sir.
0,
Greater
right?
than 0,
Okay.
but here it is not equal to 1.
It is not
Okay, sir.
equal to 1. That means there is a problem, right? There is a
Hmm.
problem. So while defining that what is the problem here? What do you think? What is the problem? This is 1 by 2, right?
Sum is not equal to 1 by 2. Total sum.
Sum is not equal to 1. Why it is not 1?
Sorry,
Because you are,
1, sir. Yes, sir.
yeah, because you didn't consider these odd numbers, right? So probability distribution is, so what is the success here? Success is what?
Getting an even number.
Getting an even number. So getting an even number. So
Sir,
if let's
can we
say,
say that
hmm, hmm,
this is
tell me.
a Bernoulli
Bernoulli
random
only,
variable?
correct. This is a Bernoulli
Yes, sir.
random variable, right? Because if you see x equals to 1, x equals to 1 is what?
For success. For success,
Success.
getting
So
an even
yeah,
number.
so getting an even number. So which even number? 2, 4 and 6.
6.
But the probabilities then associated with x equals to 1 will be equal to, so it will be how much? 1 by 6 plus 1 by 6 plus 1 by 6, right?
Equal
Because
to 1 by
it is like either 2 or 4
more.
or
4.
6.
6.
So you know the properties of this, right? Like, because here we have three events, right? Three different events. You will get either 2 or 4 or 6. So or means what? Addition, right? Addition of the probabilities. So it is 1 by
Yes,
6
yes, sir.
plus 1 by 6 plus 1 by 6. So if you find out the probability, it will become 1 by 2. Then
Yes, sir.
so this x equals to 1 is, I represented this success as 1.
Success.
Okay, this I'm just representing this. 1 is a representational number, right? This is not the actual value taken by the outcomes of this, probably outcomes of the experiment, right? Correct.
Yes, sir.
Okay, now you understand. So I can actually, instead of 0, I can keep this as -1 also. Understand? So -1 means what? Failure. So I'll say uh, x equals to -1 is what? Getting an odd number. Getting odd number. So odd number probability is 1 by 2 again, right? I can keep this as 1 and 2 also. This x equals to 1 and this x equals to 2 is actually a representational number. But in general, to avoid the confusion, what we are saying is, because I say 1 as uh, success and 0 as failure. So x equals to 0, it's a failure. Failure means it's not actual failure. It means I'm actually defining success as getting an even number, and hence this is a complement of that event, right? So getting an even number is 2, 4, 6. So the probability associated with it is equals to 1 by 2. Why I said
Yes,
that?
sir.
Because I am getting either 2 or 4 or 6. Similarly, getting an odd number is, I'll get either 1 or 3 or 5. And if I add all these probabilities, it will become 1 by 2. Understand? So this is actually a random variable, right? Okay. This is the definition of a random variable. Now you understand what is random variable?
Yes, sir.
Okay. So
So can we also say is that the Bernoulli trial?
yes, this is a Bernoulli trial, or I guess a Bernoulli experiment. I don't know, like you guys have studied it or not, but this is a Bernoulli. So Bernoulli actually is what? It's like either I'll get a success or a failure, right? Okay, so there will be only two outcomes possible. Here also, either I'll get an even number or I'll get an odd number. So that is there. Okay, maybe I'll take another example. Okay, so consider any random variable x. Okay, now you understand, right? Like how this 0 and 1 is coming. Fine. So I'll take one another random variable which says uh, okay, how fine. So let's say I say there are this is a random variable and the probability is associated with is with that x equals to x is, let's say, getting one is, let's say, okay, is this a valid probability distribution? Hmm? Is it a valid probability distribution or not?
No, sir.
Why not?
Sum is not equal to 1.
Hmm?
Yeah,
Sum
sum
is not
is
equal
not
to
Sum is
equal
not
to
equal to
1.
1.
right. Okay, sum is not equal.
Sir, addition of all these probabilities must be 1, na?
Correct. So this is not a valid probability distribution, right? So this is 1 by 2 plus 1 by 3 plus 1 by 5. So if I do the calculations, it will become 1 by 2 plus 5, 8 by 15, right? And something like this. So it is actually more than one, right? So this is not a valid probability distribution. To have this kind of distribution as valid probability distribution, we need to have the sum as equals to 1. Okay, so until now this is fine, right? So you know how to define a random variable and how to find a probability distribution, and you have to check the validity of the validity of probability of distribution of a random variable. So I'll take that same example again here of a coin toss. Okay, so this is I'm saying uh, this okay, this is a valid probability distribution, right?
Yes, sir.
Right. Okay. Fine. So now I'll define a term for a discrete probability distribution, the expectation of a random variable. So what is the expectation of a random? So, have you guys studied about the continuous random variable in week 9?
Yes,
No,
sir.
sir.
We only
A
Yes.
little touch,
little bit, sir.
but
Not
not
much.
questions, sir. It is on, I think, week 12.
Only discrete.
Only discrete. Okay. Fine. Okay. No issues. So in discrete random variables, which random variables have you studied?
Questions on random variable, discrete, sir. And we have only studied the definition of continuous.
Okay, fine. Okay, then it's okay. So let's say I'll just go through the what is the expectation of a discrete random variable. Okay, I'm not going into the definition of continuous random variable right now. So discrete, what is the expectation of a discrete random variable? So this is nothing but summation of x into probability of x. So what this small x represents here?
A
Sum of,
random variable.
let's say I'll say I cannot say I equals to 1 to n, but sum of all the products of that value of a value taken by a random variable and the probability of that random variable.
Probability.
So this is the definition of expectation of a random variable. Okay. So in this case, the corresponding to this random variable, what do you think the expectation of x will be? So expectation of x is equals to sum of, so x is, when I take x equals to 0, right? 0 into 1 by 2, right? Plus this 1, right? This 1 into its corresponding probability is my expectation of a random variable. So what is the expectation here? Equals to
1 by
1 by. So this is the expectation of this random variable. I'll define the variance of this random variable as variance of x. It will be denoted by this
Sir,
VAR
I
of x.
just joined. Could you please tell what are you telling? Sorry.
Sorry.
So I just joined. Can you please tell what are you explaining? What have you been doing till now?
Okay, so initially we have started with week 9. So actually I'm going through the summary of week 10 today. So initially we have started with what is random variable. Okay, generally I've started with random. What is random experiment? Sorry, what is an experiment? What are the outcomes of that experiment? And
Okay, sir. So now what are you doing, sir? Can you please tell?
expectation of that random variable and variance of random variable. So this is the
Okay, sir.
definition of a expectation of random variable. Okay. So this is the probability distribution of random variable. Okay, typical. So this generally will do probability distribution in this tabular format. And okay, I'll show you another way of showing this distribution, which is, let's say, probability that x equals to small x. This will be shown by like this, right? So it will be, probability will be equals to half when x equals to 0, equals to half when x equals to 1. This is another way of showing the probability distribution of discrete random variable. Okay, so this is the definition of expectation of a random variable. So expectation of x is equals to summation of products of this value taken by random variable and the probability associated with that value, right? So expectation of this example, or the random variable showing in this example is 1 by 2. What is variance of x? So the formula to find of variance of this random variable is expectation of x square minus expectation of x to the whole square, right? Okay, this is the formula for variance of x. Okay, I will show you how to find the variance for this distribution. Can I remove this one? Okay. I'll use it later. This is what, this was a PMF of a random variable, right? Okay. So how to find have you guys studied these functions of random variable?
Yes, sir.
You have studied, right? So you know, if you are given the uh, probability distribution or maybe PMF of random variable, how to find the probability distribution of a function of random variable, right?
Yes,
You
sir.
know that, right? Okay.
Yes, sir.
Okay. So yeah. Okay. So if this is the formula for expectation of x, what do you think? What is the formula for expectation of x square?
Just square x term
So
and
it will be x
multiply
square into,
CA
right?
probability of.
Right? Fine, right?
Yes, sir.
Yes,
Okay.
sir.
Right.
It's
So okay. And let's say, okay, what is x square actually? It's a function
So
of,
the x is 0 and 1, you have to multiply 0 square, 1 square into the probability of that
that
h.
is fine. Yeah,
Then
that is
sum it
true.
up.
That is true. But in general, what is expectation? If I ask you what is expectation of 2x, what will you do?
just multiply by 2
2
X.
Right? Right?
Yes, sir.
Understand? Okay. So okay, now you understand this one. So let's say okay. So how now for to find out the variance of x, I need two terms: expectation of x square, and I have already found out expectation of x here in this first step, right? So now I wanted to find this one, this one. Okay. So what is expectation of x square? So it is nothing but summation of x square into probability of x. Okay, true. So now tell me how to find expectation of x square here. In this case, this problem, 0 square into probability of x, which is
Into
1 by
half
2
plus 1 square.
into 1 by 2. So again, this is 1 by 2. Okay, so what is variance of x now? I'll substitute this value here. This will become 1 by 2 minus expectation of x is 1 by 2 square, which is again 1 by 2 minus 1 by
1 by
4.
4.
So this is 1 by 4. So this is my variance of x. So if I know variance of x, can I find standard deviation of x
Yes, sir. By squaring the root.
by taking a square root, right?
Yes, sir. Square root.
So standard deviation,
Can you please
It
scroll across just a
it
minute?
becomes 1 by 2.
yeah,
Okay, so thank you.
right? So sigma is equals to root of variance of x, which is equals to nothing but root of 1 by 4. So this will become what? 1 by 2. Okay. This is the probability and okay, now if I wanted to do it graphically, how will I show this one? How will I show this random variable and expectation variance on the graph? So I don't know like if this is required or not, but I'll just try to show it. Maybe you guys have seen PMF, right, in the week 9.
Yes, sir.
So can you tell me how to draw this PMF here? So this is x, right, and this is probability of x equals to small x, right? So I have 0 and I have 1. So the probability associated with 0 is, let's say, half. Oh, okay, okay, okay. This will be like this, right? Right? Is correct?
Yes, sir.
Okay. What does uh, what does this expectation show? Expectation of x is 1 by 2. That means where it will be lying.
1 by 2.
Hmm?
Same as
Okay. Where is 1 by 2? Here. Where should I show the expectation here? Okay. Expectation is nothing but a mean, right? What is the mean here?
Mean is half.
Hmm. Okay. But where should I show it?
Sebastian
In
showed
in
means what
between
does
0.
it mean, sir? Sebastian showed means in the graph you're asking.
Yeah, in this graph, where should I where should I show the mean here? Or okay, or
The same
what is the
as this
X
half,
X is
sir.
half and Y is half.
okay. Actually here, right? This is the mean, right? Mean of the value. And 1 by 2 is here, right? I can maybe show this is not required, but I'm just for any distribution, right? If you see any kind of distribution, so I think all of you are familiar with this kind of graph, right? The normal distribution graph. Maybe you
Yes,
guys
sir.
haven't seen this Bernoulli distribution very frequently, but I think you guys have seen this one, right? The the graph of normal distribution, right? Okay, I'll show you. I think then you will be able to realize what I'm trying to say here. This is kind of a bell-shaped curve, right? Right?
So here the half must be in the value of x, capital X.
Yes, correct. Value half will be value of x. It will be on x. That's why I written it there, right? Half here, because this is expectation of x, expectation of random variable, right? Correct. So if my zero, so it should be between 0 and 1, right? Expectation should be in between 0 and 1, right? It cannot go on the y-axis. This is very important concepts actually. What I'm trying to show you is because this again will be useful in statistics too. So that's why I'm trying to show you. So have you guys seen this kind of curve somewhere?
Yes.
Right. So let's say this is 0 1 curve. Okay, what does that mean? 0 1, 0 is what? Mean, right? 0 is mean, right? Here let's say this is 0 and this is nothing but this will be said that as mu, but which is nothing but expectation of x only, right? And this 1 represents what? Standard deviation. So it shows the spread of the distribution, right? So 0, you can see 0 is on x-axis. This is what? On y-axis, what is this? This represents actually the probabilities, right? But this is not, this is a continuous curve, continuous distribution, right? Hence it will be like this. So here in case of a discrete distribution, this half will be, because you are understanding my point, right? What is it? What is the expectation of x? It cannot go on y-axis, right? Because y-axis is probabilities associated with it, right? Expectation of x should be on x-axis. So if what is expectation? It is long time average of, so if I toss a coin for sufficiently large amount of time, I should get half, right? So this is actually a meaning of it. But uh, actually this is not the value taken by any because I'll get a head or a tail, right? I'll get a head or tail, and I'm representing this by 0 and 1. But the distribution should lie around 1 by 2. So around 1 by 2, and the standard deviation is 1 by 2, right? And that is we have found here. Standard deviation is 1 by 2. So the spread is 1 by 2 around the mean 1 by 2. Understand? This is the meaning of it, and this is a graph it should be looking like. Okay, it's okay if you don't understand this at this point. It's okay. So it's not a problem. But do you understand this one?
So can we see the deviation is the standard deviation, the deviation of the curve from the expectations around the x-axis on either side?
On x-axis, no. Yeah, but yeah, this is like that only. Okay, I'll tell you. Maybe I'll tell you some with the different examples. What you have studied in statistics 1 until now. Let's say before random variable, right? If I go to week 1 to 4, what we have seen there. Let's say we have these kind of values: 1, 2, 3, 4, 5, and 6. Okay, these are the values. What is the mean here? Or maybe I can take 7 here. Okay, 7, or okay, I'm not sure.
So this would be
Okay,
the
fine.
PDF for uniform, right?
Huh?
This would be the PDF graph for uniform distribution,
This
right?
is not PDF. This is PMF, right? Because this is a discrete distribution, right? It's not a continuous distribution. Bernoulli is a discrete distribution. Fine. This
Okay,
is a
sir.
PMF of a discrete distribution.
So
PDF will be
3.5 is the mean.
okay. Okay. Initially, we have seen that this is 3.5 is a mean, but 3.5 is not the value in this data set, right?
Yeah.
Yeah, but still, I know that. Okay, what does that? What is the meaning of this 3.5 here?
Uh,
That all values of this data set are around this
Ship-
value, right? So that means my this value is exactly dividing all the values in data set into the half, right? So about this point, half values are on other side and half values on one side, right? This
yeah.
fine? Correct. That is the mean. That is the meaning of it. So this is kind of a lever, right? Around this lever, all my values are equally
Separated.
or yeah, separated. Now, what is the standard deviation of this data set? Okay, see why I'm trying to show you or tell you this is because this is for understanding point of view. This is important. If you go ahead in this course or in this degree, you'll get to understand what is happening here, right? It's not just about the formula. If I can tell you the formulas, you'll mug up those formulas and you'll be able to understand or solve the questions. But that is not the meaning of this, right? You have to understand. So just tell me what is a spread of this data set, or what is the variance of this data set, or what is the standard deviation of this data set.
The population or sample?
Near sample.
Anything, whatever you want to do, it's fine. Okay, just find it out. I'll come back in 2 minutes. I'm take 2 minutes and just try to solve this.
So the sample standard variance would be 3.5.
Okay, what is the standard deviation? Anybody has found out? Hello, am I audible?
Sample standard variance would be 3.5 and the deviation would be root 3.5.
Okay, what is it like? Root 3.5 is means like
Sir, S
around
squared
1 point
3.5.
something like this, right? 1.75. It's
Yes,
not
sir.
2. I don't know. Okay, let's say it's 1.75. What does that mean? The spread of these values is like this, right? I don't know. Maybe. Huh? Correct? So the values, how they are spreading it around that mean, that is it showing, right? Similarly, in case of random variable, if I find out the expectation of x and the standard deviation of x, what does that mean? The if I do this experiment for much longer time, what will happen? What will happen? My mean,
Find out how many values lie within 66% of the
yeah,
like
66%. Okay, but that is okay. That is another thing that is applicable for this
normal
distribution,
distribution.
normal
Yes.
distribution. But in general, the essence of it is, if I do this experiment multiple times or so like longer time, I'll get half as the average value, and it is spreading around half. So you can see, right? So around this half, so either I'll get 0 or 1, right? Most of the time I'll get 0 and 1, 0 and 1, 0 and 1, right? That is the meaning of it, right? I'll get either 0 or 1, either get 0 or 1, like this, right? Okay, so I'll take another example and you tell me if you are able to understand it or not. If I toss a coin, and this time I tossed a biased coin, okay, biased coin, and I say that the probability of getting head is equals to 0.3. Can you tell me, and if I say the random variable is x, okay, it is defined as, okay, maybe I can say uh, the outcomes of, or if I define x as getting head as a success, okay, can you tell me how this distribution will look like?
The probability of getting no head, it will be 0.7. X
So
equals to
yeah, that
0.
is okay. No, I'm okay. But can you tell me the distribution? How it will look like?
It will be 0 and 1. X will
Point
Okay,
be 0,
three and 0.7.
0.7,
0.7, 7, and 0.3.
0.3. Okay, fine.
And
This is
point
the distribution. But this is when I define x equals to 1 as success. Success means getting a head.
Head.
Okay, fine, understandable. Okay, now can you tell me what is the expectation of x?
0.3.
So this is what this sum of this. So this is equals to 0 into 0.7 plus 1 into 0.3, which is nothing but 0.3.
10.
Okay, what is variance of x? It is expectation of x square minus expectation of x to the whole square. Okay, so what is expectation of x square now? It is nothing but summation of x square into, I'll write this like this. Okay, it's fine. So this will become x square is 0 square into 0.7 plus 1 square into point.
Point 3.
So this will become 0 and this will become point, which is expectation of x square, right? Okay, now what is variance of x? Variance of x, I'll substitute value here. 0.3
Root
minus
point.
0.3 square. So 0.3 minus this is what, 0.09, 0.21 is the variance. Okay, until now this is okay, everyone is fine with this,
Yes,
Yes,
sir.
sir.
right? Okay, so this is variance of x. What is standard deviation of x? Root of point.
Root of 0.21.
So if anybody can tell me the value, some exact value in two, until 2 decimal places is fine.
0.45.
0.445. Okay, done. Fine. So how should I draw this on the graph? So let's say I wanted to draw the graph. Okay,
The
the
x
graph.
axis will
So
take random variable.
this x is probably that x equals to small x. Again, I'll have 0 and 1, right?
1. Yeah.
The probability associated with is equals to 0.3, and for 1 is, oh sorry, I think this is 0.7, right?
Yes, sir.
Yes, sir.
Point 7. For 1, it is point 3.
Okay, so this point,
Acha, ये-
huh? Okay, is fine.
Yes, sir.
This is my PMF. Okay, I shouldn't
If
join
we
this
scroll
actually.
up, sir, because
Yeah.
I got logged out now. So just a minute.
Fine. I'll keep it here like this. Okay.
Yes, sir. Thank
This okay?
you.
We started with this. We tossed a biased coin. I said that probability of getting a head is 0.3. Now I found out the probability distribution for it, right? And then I found out expectation of the x which is 0.3. Then I wanted to find this variance of x square, right? For that I found out expectation of x square, which is 0.3. I plugged in this value here. Then I plugged in these two values into this formula, and then I got variance of x as 0.21, and now I got standard deviation of 6.
Yes, sir.
Okay, what is expectation of x now in this case? Okay, where should I write down?
0.3.
Should I? Here or here?
Near about 0.
Right, near to 0.
0.
Okay, this is 0.3. Okay, this is my expectation actually. Okay, and what is the variance?
0.21.
0.2.
Less than the 0.3.
Okay, that is fine. Okay, that is not the thing. What are you understanding from here? uh, what do you feel like, why this expectation is moving towards 0 and not towards 1? Why? What do you think, why this is happening? Previously what we have seen, that this is like, actually it was in the middle, right? It was in the middle, and I was like getting, okay, half this side and half this side, but this is not the case here. What is happening here?
Because it is a biased point, that's why we are getting.
Yeah, biased point means what? Okay, you are getting it. So what do you mean by biased point, and why I'm getting it closer to 0, not to the 1?
On that one.
Actually it is, actually if you think, this is because of the probabilities associated with it, right? So it is very much probable. So 0.7 is the probability that I'll get a tail, right? So what do you mean by, so what is happening? There is a chance that I'm getting tail more number of times. So if I, let's say if I toss a coin 1,000 times, okay, 1,000 times, maybe I get a, what is the chance that I'm
So the
getting a tail?
variance of x, just a minute, sir. Variance of x is 0.21. 0.3 has to be marked on the x-axis.
Sorry,
The 0.3 marked is the variance of x only, right?
0.3, this 0.3
Yes, sir.
here, no, this is expectation.
Okay, sir.
Okay, this is expectation. See, you cannot mark variance on x-axis, right? You can mark expectation of x. Expectation of x is actually, this is the, this should be in the range of random variable, right? So what is the range here? 0 and 1. So the expectation should always be in between 0 and 1, right? In this case, it should be like that,
Yes.
right? It cannot be outside the, so mean cannot be outside this range, right? It can be either 0 or it can be 1. This is generally as that of your mean only, right? So okay, I'll tell you what is happening here. Suppose I tossed a coin 10 times. In the first toss I got head, second toss I got head, then tail, 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 head, head, or maybe, okay, I'll say tail, tail, 1 2 3 4 5 6 7 8 tail. Okay, in this case what is happening?
3 times head and 7 times.
So 3 times. So actually I'm getting the probability from this experiment only. So I'm saying the probability is 1 by 3, not 1 by 3, sorry, 3 by 10, right? Order tail is 10, and I'm saying that, if I, okay, so if I, okay, if I toss again the coin for more, let's say again 10 times, what will happen? I'll get again, so there is a chance that I'll get tail in most of the tosses, right? Because that is my probability associated with it. Our understanding point? No. See,
Hello, sir.
probabilities. Yes.
Sir, I have a doubt in a property of expectation. There is a property EAX plus B equals to EAX plus B.
That is okay. I'll come to that. That is fine. After this, I'll discuss properties only. But give me the answer for this question now first.
Okay.
So can you please explain the question?
The question is, so let's say if I have this probability associated with it. Okay, probability of head is 0.3 and probability of tail is 0.7. What is the meaning of it? So if I know probability of head is uh, 0.3 and if I know probability of tail is 0.7, what do you think if in the next 10 tosses or in the next toss, uh, what will you get? What is what your what, okay? If I toss a
Yeah.
coin again, what I'll get?
We find expectation.
Expected.
Around 70% time we will get tail and 30% we will get head.
So that is the chance that okay, if I know probability is 0.3 and of getting ahead is 0.3, or okay, I'll tell you some other example maybe. If I wanted to do a bet, okay, if I wanted to do a bet and you are there and if I'm there and I know that this probability of getting head is 0.3, probability of getting head is 0.3 and probability of getting tail is 0.7. So you said if you are going to toss again, okay, toss that coin again, and if if I say that head will come, I will get 10 rupees, and if tail will come, you'll get or if the tail will come, you'll get 10 rupees. So in that case, what is the chance that or what is the what do you think that who is better here or who is having the greater chance to getting the 10 rupees?
Tail.
Me or you?
Tail.
So that means you, right? So it is possible. See, if you guys toss a coin and once, it is possible that it will land on head. But you know, since you know this is unbiased coin in the and how to find these probabilities, we have found its probability by doing the prior experiments, right? How do okay? I know that. How do you, okay? Let's say I have tossed the coin in 10
Actually,
times.
your
It
voice is very low, so I'm sure it's
for everyone is low or it's fine.
Yes, sir.
Is it slow?
Yeah. No, sir, it's fine only.
Yeah, it's okay, sir.
Okay, maybe I'll check my mic. It's not. Okay, this is fine now. It's okay.
yes,
Yes,
sir.
sir.
Better.
Noise is
Okay, this is better, right? Okay, fine. So let's say how to find this probability or how do I find out these probabilities is because let's say I have done this experiment for 10 times previously, head. Let's say like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are the outcomes in the previous 10 tosses. Okay. Now so from here only I found out that probability of getting head is 0.3, probability of getting tail is 0.7. Now if I'm going to uh, toss a coin again 11 time, and I know now the bet is if I get a head or if I get a head in 11 toss, I will get 10 rupees. Okay, and if I get a tail, I'll get 0 rupees. Okay, that is chance. Or maybe if I get head, then I or
We
if
can
you
make Bernoulli random variable for this probability. For
that is okay.
getting
That is
for
not my
getting
question.
head is 0 and tail for 1.
That
Sorry,
is okay.
for head for 0.
Right. That is fine. But the question here is, whom will you bet here? For tail or for head?
Head. We'll
tail.
bet for head.
Tail, right?
Tail, sorry.
Tail, right? Because the
Tail,
probability
tail.
associated, it is
Yeah.
more likely that the tail will come in 11 toss rather than the head. But it is possible that head will also come, but the probability is very less, right? And that is what here also you are able to see. The expectation, right? Expectation which is 0.3 is more closer to this tail rather than the head, right? This is because tail is having more probability associated with it, and that is very evident from this formula also, right? Because the expectation is coming through this. We are actually multiplying the probabilities to the values. So that value of the random variable, or the expectation will be very closer to that value of random variable whose probability is more, right? Right? This is the case.
Yes, sir.
So this is also it is seen from this example. Maybe I'll take one more example, and what I wanted to show you is, I'm not sure, like, let's see one example from here. My screen is visible?
No, sir.
Okay.
Blank.
Yeah. Which example should I take? Okay. Okay. Can you tell me here? Here is this probability distribution you are able to see, right? 0, 1, 2, 3, and 4. In this case, okay, in this case, it's very difficult to say, but still, can you assume, or can you directly tell me, predict that where the expectation will lie by looking at the probabilities?
Between 2 and 3.
Between 2 and 3, or it will lie between here, 0, 1, and 2, or something.
0
Or
and 1 and 4. 0, 1 and 4.
Hmm? Okay, do you want to try this out?
Sir, nearest to 2. 1 or 2.
Okay,
Nearest to
let's
2.
nearest to 2, that is okay.
Yes.
Nearest to 2, that is okay. But whether it will lie between 2 and 3, or 1 and 2?
1 or 2.
1 and 2.
1 and 2. Why? Because you can see that probabilities are higher on this side, right? 0.5, this is 0.25 plus 0.25, it's 0.5, and here it's 0.6, correct? So, and here if you see the probability, it's 0.25 plus 0.15, it's 0.4. So most likely it is this side, but if we can try, we can see that, we can calculate. So can you tell me the probability distribution here? So how to, okay, I'll write in this way. Okay, so x equals to 0, I think x equals to 1, x equals to 2, x equals
Sir,
to,
can you zoom in on the page?
which one? This one?
Can you zoom in on the page? Yes, sir.
This one? Okay. Can't zoom. 1 minute. Okay, this is fine. Visible, right?
Yes, sir. Yes.
Yes, sir, good.
Yes.
Okay, so we have the values taken by random variable as 0, 1, 2, 3, and 4. Okay, 0, 1, 2, 3, and 4. What are the probabilities associated with it? Are 0.25. Here, this is 0.25, I think. This is 0.1. X equals to 5 is not there. Okay, so here this is 0.15, this is 0.25. Correct? This is a probability distribution here, right?
Yes, sir.
Or in tabular format, it will look like this. Is 0, 1, 2, 3, and 4. Now this 0.25, 0.25, 0.1, 0.15, and 0.25. Okay, fine. What is the expectation of x? This is sum of x into x. Okay. What is the 0 into 0.25, right? Plus 1 into 0.25 plus 2 into 0 0.1,
3 into
0.15 is 4 into 0.25. Is 0 is 0.25 plus 0.2 plus 0.45 plus 1, right?
0.1.
No, 0.1. I think it's 1. Okay.
Once.
So this is 0.4 plus 5. This is 0.60 and this is 1.8. This is 1.8. Right? This is the answer. So 1.8 is where?
I think it'll be 1.9, sir.
4, 5 plus, yeah, 5. Okay, 70, right? This is 0.9. Okay, so you can imagine, like you can see this 1.90 is here, right? In between 1 and 2. So our guess was correct. So the expectation of x will lie between 1 and 2, right? This is evident, right? If you see the
How
all
did
the
you
probabilities,
find out it lies between 1 and 2? Like the distribution of probabilities.
we can see in the probabilities, right? So generally this is the, see, it is like the higher the probabilities, your expectation will be on that side, right? So you can see the sum of all the probabilities here until 0.2 is 0.6, right? From this side it is only 0.4, right? Right? So most likely it will be lying between 1 and 2.
So it
This
lie
was
between the side which is having higher probabilities.
correct, right? Because this is the
Yes.
formula, right? This is the formula. So if you see those who are having higher probabilities, expectation will be on that side. Okay. So this you can see that so 1.90 it's towards that between 1 and 2. So this is one case. I wanted to show you one more case. I think this is very important in perspective. So if I toss uh, a coin, okay, if I toss a coin, and this is unbiased coin. So and let's say I said that this is the case. So I assume x equals to -1 as getting a tail and x equals to 1 as getting a head. Instead of 0 and 1, I am using -1 and 1. Is it correct or wrong?
Sir,
Sir,
Yeah,
how
you
it is
can.
possible, sir?
It is possible, right? Why not?
Yeah, yeah.
sir, how
So
can we decide that we can take -1 or
okay, this
0?
is arbitrary. So taking the values of uh, random variable are arbitrary. Okay, but generally to understand for everyone, we take x equals to 0 for failure. Failure in this case, not getting ahead, and x equals to 1 for a success. Okay, but I can take any values, any values to that random variable. There is no problem in it. Okay, so can you tell me what will be the expectation now? In previous case, what was the expectation when I said x is 0, 1 and probability of x equals to x as 0.7 and zero point 0.3? What was the expectation? 0.3, right? Right?
Yes, sir. That's point
Right.
three.
So now in this case, the expectation will be the same or different. What do you think the expectation will lie?
Near -1.
Expectation near -1.
-1 to
So
0.
in that case, will it be 0.3 again or it will be different?
-1 to 0.
The
It will be
value of
different.
expectation may be different, but it will lie near to the -1.
Correct. So now you see what is the value? it's minus point 4,
Yes, sir.
right? So if I wanted to draw here, it will look like this. Let's say minus 1 and 1. Okay, this one. But if you see, this is point 0.4 will be somewhere here, right? Because the middle value of this is 0, right? So point 0.4 will be near to this minus 1, and this is my
So the
expectation.
expectation of x will lie near to the x value, which has a greater probability. Can we just say
Right,
this?
right. This is the essence of it. Okay, this is the importance of this expectation, and you can think of it. It's not a difficult thing actually. So let's say I'll show you in the with respect to the data set. So suppose I have 0 0.
Sir, can you explain one more time?
Yeah, I'll do one. Just give me the case. So in this case, how many times 0 is occurring here?
6.
6 times. How many times 1 is occurring?
3,
How many times 2 is occurring?
2,
2.
And how many times 3 is occurring?
1.
1. This is a frequency table, right? The general frequency table.
Yes, sir.
How to find the mean of this? Or okay, what do you think the mean will lie where? Will that be near to 0, near to 1, near to 2, or near to 3? What
Near
do you
to
think?
0.
Near to 0.
It should lie near to 0. But okay, that is because I knew. But now just tell me how to find the mean here. So mean will be, let's say it's 0 plus 0. Okay, I'll directly write as 0 into 6, right? Now you are comfortable with this, right? 0 into 6 plus 1 into 3 plus 2 into 2 plus 3 into 1 divided by
Well,
10, right?
12.
Okay. 6399. Okay, 12. Fine. Right. So this is 3 plus 4 plus 3 by 12. So I think it is 10 by 12. So 10 by 12
5
is,
by 6.
yeah,
5 by
something like this, right? Or some numbers. So it is 0.83, right? It's 0.83. So you see it is lying between 0 and 1, right? Is it correct?
Yes, sir.
So you can actually, so this is nothing but a probability, right? So if you see what is the probability of occurrence of 0, it is 6 by 12. Probability of occurrence of 1 is 3 by 12. Probability of occurrence of 2 is 2 or 2 by 12, and this 1 by 12. So if I 6 by 12 is 1 by 2, 3 by 12 is 1 by 4, 2 by 12 is 1 by 6, and here it is 1 by 12. So which is have, which probabilities are the greater here? These two, right? Right. So I'm sure that definitely the mean will lie in between these two values, 0 and 1, and this is evident here. And mean is nothing but expectation of random variable, and here also you can see that. So here the probability associated with this value is higher, and hence the mean will lie very closer to that value. Understand? So probabilities are actually coming from where? Coming from the relative frequencies only, right? If you have large number of times, like if you are doing that experiment for large number of times, you will get the probabilities for those values, right? Give me a moment.
Sir? Sir, are you speaking something?
No, sir is not a speaking something.
Yeah.
Anyone from Sundarban house here?
Hey bro, can I ask something?
Are you asking for me?
Yeah. So when will get your house after the qualifier? Actually, I
Bro,
didn't get
actually,
the.
I am J entry. So,
So basically all JNTs got their house.
हाँ तो क्या
No,
हुआ था
even I'm
ईमेल
saying
ईमेल में आया था मेरे पास तो डिटेल्स
Hi. Okay. Stop it. So yeah. Until this is fine, right? Everything is okay. So that means you can assign any value to represent a random variable, but generally the values given by the random variable are very easy to understand, right, to everyone. Okay. So now we'll take one more example from this assignment here. This is the question, right? Question number 4. So let's say probability of, let x be how much, let x be how much you win in a lottery, and in the lottery we draw a random number outcome between 1 and 1000. The price is computed as follows, right? So this is the price, or okay, you'll get 0 rupees when you draw a number between 1 and 700. You'll get 4 rupees when you draw a number between 700 to 950, and similarly like this. So you'll get 1000 rupees when you draw a number between 999 to 1000, and assume that each outcome is equally probable. So what is the probability associated with x equals to 0? Hmm? Okay, what is the experiment here? So experiment means
Winning rupees in lottery.
huh?
Winning rupees in lottery.
Is that experiment, or the experiment is drawing a card
Drawing a
or
random
drawing a
number.
number? Yeah, drawing a random number is an experiment, right? The
Sir.
winning some amount is associated with the that random variable, that is fine, but once you draw some number, based on that number you will get the winnings. Fine, is correct, right? So here the experiment is drawing a number, and we are saying that, and what is the outcome of this drawing a random number? So I can actually have 0, 1, 2, 3, 4 until I can draw any number between 0 to 1000. And what you have said that each drawing a number, right, or drawing this outcome, each will have the equal probability, right? Correct, right? So what is
Yes.
the probability associated with this? So let's say simple. Yeah, yeah, simple. Okay, I'll give you the simple example. If I say I toss a coin, and what I'll get, head and tail. What is the and if I say getting head and tail is equally likely, or getting this outcome is equally probable. So what does that mean? What is the probability of getting head?
1/2, 1/2.
Okay, 1/2. How do you find it? Because the total number of outcomes is how many?
Two.
Two, right? Okay, and I divide.
Two.
So if how do
Yeah.
I get the probability? 1/2. So the probability definition is what? total outcome in the
Favorable by
denominator.
total outcome.
Yeah, it's favorable by total.
Number favorable.
So yeah, so if I say each of this drawing this number is equally likely, what does that mean? What is the probability that I'll get one? So what is favorable here? Or let's say 0, 1, and total is 1000, right? I think it is not from 0 to 1. Okay, this is from 1 to 1000, right? Okay, sorry. Because if it is 0 to 1000, then that means it should be 1 by 1001, right? Okay, so what is probability of getting 2?
1 by 1000.
1 by 1000. So similarly, each will have this probability. Fine, this is okay. Okay, now the random variable is x, which says that if I'll get 0 rupees if I draw a number between 1 to x. I can say this is xp, how much you win, right? Okay, I think this is something problematic here, but let's say, okay, let's say if this is between the number we are drawing is between 1 to 700, I'll get 0 rupees. Okay, similarly, if I'll get 4 rupees when I draw a number between 700 to 950, 700 to 950. Okay, 950. So what is the probability that I'll get x equals to 0? X equals to 0 means my winnings are, or I can say my winnings are 0 when what is
Say
probability?
1000.
It will be 700 by
700 by
1000, right? Similarly, probability that x equals to 4. I should say actually
950 minus 700
700.
by
so how much it is?
1000.
It is
250.
250 by
250 by
1000.
1000.
probability that x equals to 10 is
10.
40 by 1000.
40 by
40 by 1000.
1000.
30 by 1000. Okay, so okay, let's draw a table now. So let's say x is
Sir,
taking
can you
values.
please explain again the one step? How you got that answer?
Okay, generally what is probability?
Favorable outcome upon total
Or
outcome.
total outcome. So how many outcomes are here? If I draw a number 1 to 1000, so total outcomes are 1000. So if I wanted to have number 1, what is probability of it?
1
It
by
is
1000.
1 by 1000. If I wanted 2, what is the probability? 1
1 by
by
1000.
1000. Okay, so I said that I'll get 0 rupees if I get a number between 1 to 700. So that means either I'll get 1 or 2 or 3 or 4 or 5, like that
Or
until
either you get 700.
700, right? So I need to, what I need to do, I have to add each of this probability, right? Probability of getting 1 plus probability of getting 2 plus probability of getting 3 until probability of getting 700. So what is it? So 1 by 1000 plus 1 by 1000 plus 1 by 1000 until,
700 by
so
7.
this is 700 times, right?
Yeah.
Correct. So this is 700 by 1000. So and in that case I will get how many rupees? 0 rupees. So what is probability that I'll get 0 rupees? Is
700 by
700 by 1000. So which is nothing but I'll say 0.7. Right. I'll get 4 when 4 rupees when my number is between 700 to
950.
950. So this is what? Yeah. So this is what?
250 by 1000.
So this is 250 by 1000, which is nothing but 0.225.
25.
Okay. I'll get 10 rupees when
40 by
40 by 1000.
40 by 100. So this is
And
what? 0.04. Okay, I'll get 100 rupees when
9 by
1000.
this is 0.009, right?
Yeah.
Right? And I'll get 1000 rupees when
1 by 1000.
which is 0.0.
0.
So is this correct? 750, 900 to 990, 990 to
Actually,
90.
these are which questions, sir? These are from which assignment or something?
Practice assignment, week 10.
Okay, sir.
The total is not making. Right. Okay.
So is it
Is
okay?
equal to 1.
40, 40, and this is 90 to 99 is how much?
So actually, it's just from week 10. So because in my practice assignment, I'm not getting these kind of questions.
Yeah, this is week 10 only, right? I think today's session is week 10 open session, no?
Yes, sir. But
Yeah.
Yes, sir.
which activity or which practice is this, sir? Because
Week 10 practice assignment,
okay, sir.
right? Okay, but I'm not sure like where I did the mistake. 1.75. It's probability of getting 10 rupees is this is what 700 divided by 1000, which is 0.7. 700 to 950 is how much?
Total is okay. Is equal to 1. All the probabilities.
1 to 700 is how many points? All
0.7.
700. 700,
This is
0.7. So,
0.25.
so it is 700 to 1 to 950 is 250 divided by 1000. That is fine. 950 to 990 is how many?
40 divided by 1000.
40 divided by 1000.
0.04.
Okay, so this is 90 to 99.
9 divided by 1000. 0.009.
Okay, is it 9 divided by 1000 or 10 divided by 1000? 91, 92, 93, 94, 95, 96, 97, 98, 99. Okay, it's 9, 9 only. It's 9.
9 divided by 1000.
Okay, okay. I think this is correct. Okay, fine, fine. That's correct.
It's correct.
So if I add all these probabilities, this is one only, right?
Yeah.
Yeah, that's fine. Okay, done. So the question is, what is expected winning? So expected winning means expectation of X. Okay, by looking at this probability distribution, what do you think? Where my expectation will lie?
Near to 4.
Or I can say, yeah, near to 4 or maybe in between 4 and 10,
In
right?
between. Yeah.
Between 4 and 10.
So yeah, this is
Between 4 and 10.
yeah. Let's check out. So 0 into 0.7. I'll just write it down like this: summation of x into probability that x. This is 0 into 0.7 plus 4 into 0.25 plus 10 into 0.04 plus 100 into 0.009 plus 1000 into 0.001. Okay, this 1 plus is zero point 0.4, right? Plus 0.9 plus 0.1, right? So if I calculate it, it will become this one is correct. 100 into 0.009 is how
0.4.
much? It's correct, right?
2.4.
2.4,
Yes.
right?
Yeah.
So 2.4, this is expectation of x, and you can easily predict that okay, this is fine, right? So it is between 0 and 4, right? So if you see the more probabilities are associated to 0 and 4, so that means definitely expectation will be in between 0 and 4, and it is closer to 4, because if you see the cumulative distribution of this PMF, you will see that the measure of majority of these probabilities are between 0 and 4 only, right? This is 0.7 plus 0.25. So expectation, right? Okay, done. So this is it. So this is expectation of x, and this is the value, right?
Sir,
Yeah.
So above
1000
calculation
multiplied
is
by point
wrong,
zero zero
I
one is
think.
1.
And again, 4 into 0.25 is equal to 1, I think.
Okay, 1000 1 by 1000 into 1 by, okay, right, this is correct. Okay, 1, and here 100
And
into
4 in
It is written 1.
4 into 0.25 is equal to 1.
it's 3.4, right? Right?
Yes.
4 into 0.25 is 1. This is correct. This is 1. This 1. 10 into 0.04 is this is also fine. This is 0.4, and this is zero point 0.9, and this is 1. Okay, done. It's 3.3, right? 3.3. 1 plus 1 2, and this 13. So it is
Yes.
3.3. So expectation of x, yeah, again is fine. So it is very much closer to 4, and it is in between 0 and 4, that we can suggest. We can think, we can look at, by looking at the distribution we can tell about that. And so this is one of the actually checkpoint also, right, to see whether whatever answer you are getting, it's correct or not, right?
Yeah, but so according to us, like it isn't between 4 and 10.
No, it should not be 4 and 10. So it is again it's around 4, but if you see the probabilities on this side is 0.04, 0.009, 0.001. They are very less, right? And about this point, if you see the probabilities, so whatever the addition of these probabilities is there, it is much lesser than the probability of 0 only, right? So it is definitely,
Yeah.
it will lie between 0 and 4, not between 4 and 10. Correct?
Okay, sorry.
Right? No, that is fine, right?
Sir,
So
can you explain again how 3.3 is come?
this is easy, no? This is the formula. Expectation of x is what? Summation of x into probability of x. So what is x? X is the values taken by the random variable. So this is my random variable. What are the values taken by 0, 4, 10, 100, and 1000? So 0 into its probability is 0.7, right? Plus 4 into this probability 0.25, 10 into 0.04, plus 100 into 0.09, and 1000 into 00. This one. So if I do the calculation, I'll get 3.3, right?
Sir, last answer is 2.4, na?
No, that was actually wrong, because I think here we have done the mistake. No, 1000 into 0.001, I wrote it as like 0.1, but this is actually 1. That's
Okay,
why this.
okay, that's right.
Okay. Yeah, this was a calculation mistake. Okay. So next up is let's say we'll see. Oh, what is this first question? If I see, suppose that the random variable x can take values 1, 2, and 3. If expectation of x is equals to 2.2, and probability of that x equals to 2 is equal to probability of x equals to 3, then find the probability of x equals to 1. Okay, how to find these values? So what is x? X is taking values 1, 2, and 3. Okay, what we have given here is probability that x equals to 2 is equals to probability that x equals to 3, and we have given expectation of x as 2.2. We need to find how to find this thing. First of all, I will draw the probability distribution table. 1, 2, 3. This probability that x equals to x. Okay, I don't know anything right now, but suppose I'll assign probability that x equals to 2 and probability that x equals to 3 as let's say p, small p. So this is p, this is p. What is the probability of x equals to 1 now?
1 minus p.
1 minus 2p.
1 minus 2p, right?
Yeah.
Yes.
Is correct, because sum of all the probabilities should be equal to 1. So this is p plus
1,
p,
yes.
right? This is okay. This should be p plus 1 minus 2p is equals to 1, right? So this is done. Okay, what is expectation of x? Is summation of x into that x.
How do we find P of x is equal to 1 plus 1.2?
Okay, so I have assumed that probability that x equals to 2 is equals to p, small p, right? So if this is p, then probability that x equals to 3 equals to also p. This is fine, right? Until this point is fine.
Yes, sir.
Okay, let's say I don't know what is the probability of 1 here. I'm assuming this as, let's say, m. Okay, so I know from the properties of probability distribution that is equals to the sum of all the probabilities should be equal to 1, right? Right.
Okay, sir.
So this is m plus p is equals to 1. So m plus 2p equals to 1. So m is equals to 1 minus 2p. So I will write this as
Yes.
1 minus 2p. And I want, why I wanted this into 1 minus 2p, because I wanted only one unknown, right? It shouldn't be two unknowns. So here p is the only unknown here, right? Okay. So this is how we have done. Okay. Now what is expectation of x?
2.2.
This
2.2.
So yeah, just find it out. 1 into 1 minus 2p
2p.
2p plus 2 into
P.
p plus
3p.
3 into this 1 minus 2p plus 2p plus 3p. So
3p.
this will get cancelled. So this will become 1 plus
0.4.
1 plus 3p, which is equals to how much? 2.2. It is given, right? This 1.2 is equals to 3p. So I'll say p is equals to 1.2 divided by 3. So this is 0.4, right? Okay. So now the distribution will look like how this will look like on the distribution here is x 1 2 3, probability that x equals to x. This okay, this is 0.4, this is 0.4. What is this? 0.2, right? Okay. Now they have asked the question as what is probability that x equals to 1. So now tell me what is probability that x equals to 1. It's point, right? Correct answer should be point
0.2.
0.2. Okay. This is all about probability distributions, expectation, and their variance. Can you tell me what is the variance here? How to find the variance? So if I want to find variance of x, how to find the variance of x in this case? Hmm?
Yep.
Tell me. So what is the formula for variance of x? Expectation of x
X
square
square
minus
minus
expectation
expectation
of
whole square.
x to the whole square. Okay. So I have expectation of x. What is expectation of x? 2.2,
0.4.
right?
Yeah,
2.2.
yeah, yeah.
This
2.2.
is given. I
2p.
need to find this one. So I how to find this? Expectation of x square is equals to summation of x square into probability that x equals to small x. So
1 square into
so 1
0.2,
square into
0.2,
0.2 plus 2 square
2
into
square into 0.4,
plus 3 square into 0.4. So this is 0.2 plus 4 into this is 1.6 plus 3.6. This will become 3.6 plus 5.4, right? This is the expectation of x square. Now I plug in all the values in the formula. I will get variance of x as 5.4 minus 2.2 square. So 5.4 minus what is this value? Square. Right. This is
4.84.
huh?
4.84 minus.
Yeah, minus 4.84, right? So what is the value here? 9.5, so 0.56, right?
Yeah.
Yeah, so this is my variance here, and standard deviation will be root of 0.56. Okay, that is okay. Now we will talk about the okay. Any do you know any other way of finding out expectation of x square?
No.
No, I can actually use the function of a random variable, right? So x square is nothing but the function of a random variable, and if I do that, so what will happen? So let's say this is my probability distribution. So x is equals to what? What was that? 1, 2, 3, I guess, right? And the probabilities of x equals to x is 0.2,
0.4
0.4,
and 4.
and 0.4. So let's say f of x is equals to x square. What is the distribution of this function? I'll define this as y. Okay, y is equals to x square. What is the distribution of this? Probability distribution of this? So y is equals to x square is 1 square, right? Plus 2
1,
square
2, and 1, 4, and 9.
9, and probabilities of y equals to y is equals that will become
0.2, 0.4, and 0.4.
4. But how to find this one? Do you know that how did you found out probability that y equals to 1 is equals to what is it?
1 square.
So provided that x square is equals to 1, right? Right? Because y is equals to x
It
square,
is
so
equal to 0.2.
x equals to it is either plus 1 or I don't know. Like you guys know this technique or no? If you don't know, maybe I'll.
No, sir.
Okay,
No, sir.
this is easy only. Okay, let's talk about that only. This is not important for your quiz point of view. I don't know, but this is one of the techniques. Okay, maybe I'll try to show you this one, because how to find the probability distribution of a random function of a random variable. This is one of the important techniques. Okay, so let's say this was my probability distribution. 0.2, 0.4, and 0.9. So let's say I said that y is a function of x, and this is nothing but, let's say, so what you say, I don't know. Okay, x square. I'll take simple one, x square. For now, I'll take x square, or yep, x square. Okay, for now, let's say this is x square. So let's say I wanted to find the probability distribution for this. What I'll do is I will say, okay, I will find the range of this y. Okay, first of all, find range of y. What is the range of y? What is the range of x here? 1, 2, and 3, right?
Yes.
So range of y will be what?
2.
1, 4, 9.
1, 4, 9. Why? It's just plugging in all the values, right? X square
Yeah.
instead of
Yeah.
x, I will put 1, 4, and 9. Okay. Now I want to find probability that y equals to 1, right? Right? So that is nothing but probability that x square equals to 1. What does that mean? What is the square root of s? That is probability that x equals to 1, or probability that x equals to minus 1,
Minus
right?
1. Yeah.
Okay. What is probability that x equals to 1? It's 0.2.
2.
What is probability that x equals to minus 1? 0, right?
0.
0. So that
Yeah.
means probability that y equals to 1 is how much? 0.2. Similarly, probability that y equals to 4. It is probability that x square equals to 4. Is nothing but probability that x equals to 2, or probability that x equals to minus 2 is 0. And
So
here
for the P of y is equal to 1 and P of x is equal to 1, how did we write P of x is equal to 1 plus P of x is equal to minus?
sorry, it's a square root, na? So x square equals to minus 1. So what is square root of x?
So x
It
could
is
be 1
Yes,
or
one
sir,
minus 1.
it
Yes.
can be.
minus 1, right? So
Yes, sir.
that's what this is, what x equals to 1 and x equals to minus 1.
Yes, sir.
So that means either x is equals to 1 or x equals to minus 1. So when I say probability of either x equals to 1 or probability that x equals to minus 1, what I will do? I will add the probabilities, right? That is the rule,
Yes,
right?
sir.
Additive rule of probability, right? So that is what I'm actually using it. So what is probability that x equals to 2? It's
0.4.
0.4, and hence this is equal to probability that y equals to 4. Okay. So if I change the function to, let's say, minus 1, what will happen? What is the range of y then?
Uh,
Hmm?
it will
What is
be 0, 3.
0, 3 and 8.
Yeah. 0, 3, and 8.
0, 3, and 8, right? Correct? Everybody is okay with this?
Yes.
Sir, how you are taking range?
Range is nothing but the values taken by uh, uh, that random variable. Okay. So let's say if I wanted how to find the range of y. Okay. So I know what is the range of x. 1, 2, 3,
2,
right?
3. Yeah.
This is range. So when x equals to 1, what is y? It is 1 square minus 1, which is 0, right? I plug in when x equals to 2, y equals to 2 square minus 1. When x equals to 3, y is equals to 3 square minus 1, which is equals to 8. And that's how I found out 0, 3, and 8. Okay?
We are calculating it from x square minus 1.
Sorry.
Y is
Ah,
equal
yes,
to
yes,
x
yes.
square.
Yeah,
Okay.
yeah, this is the function, right? Y equals to x square minus 1.
Okay.
Okay. Now I wanted to find the probabilities associated with these values, right? So what is probability that y equal to 0? I don't know, right? So I'll just use probability that y equals to 0. So instead of y, I can write x square minus 1, right?
Yes,
Equal
sir.
to 0. So this is nothing but probability that x square equal to
1.
1. So again, this will become
Probability of
probability that x equals to 1,
1 plus
or
probability of minus 1.
1. So this is 0.
0.
Right. So again, it will come as 0.2, right? And similarly, you can check probability of y equals to 3. This will come as 0.4, and this will come as 0.4. So for all linear combinations, right? So this is actually nothing but a linear combination, right? So for all these kind of combinations, you will get the same probability as that of usual, random variable. But for some other functions, it will be different. But I think for your syllabus, it's not much complicated. But this is the method actually to find out the probabilities. This is the actual method to find out the probabilities. Okay.
So for only linear functions, there will be same.
Same probability. Yes. For other non-linear functions, it won't be same.
Okay, got it.
Okay. Done. Now we'll talk about some properties of expectation, these are nothing like these are the same as that of whatever probabilities you have seen earlier, or properties you have seen earlier associated with the probabilities. Let's say uh, expectation of, I think one of the properties is expectation of a x is equals to how much, a into expectation of x. What does that mean? And where a is a constant, the constant. So how to and one more property is variance of ax is nothing but a square into variance of x. So we'll cross check this one. So we'll take the same example as the above. X equals to 1 2 3, probability that x equals to small x is 0.2, 0.4 and 0.4. Now what is the expectation of x here? 2.2, right? Which was given already, so I'm not going to calculate it. If you want, you can do. So it is 1 into 0.2 plus 2 into 0.4 plus 3 into 0.4. This is my expectation of x, and this is nothing but 0.2 plus 0.8 plus not point 1.2, so it will get 2.2, right? It's okay. Okay, so if let's say there is one constant, so I wanted to find expectation of let's say 2x, or maybe I'll say 3x. Expectation of 3x. What will be the expectation of 3x? So as per this property, I know that it should be 3 times expectation of x, which is nothing but 3 into 2.2, which is 6.6. But okay, we'll cross check if it is correct or not. So if this is my distribution for random variable x, so 3x is what? It's a function of a random variable, right?
Yes, sir.
So if I wanted, let's say this is y equal to
Sir,
3.
it is also same for the adding a constant.
I will tell you. Yeah, I will tell you. No? So we'll look one by one into this. So let's say y is equals to 3x. Okay. So what is the distribution for y? So range will be 3, 6,
9.
9. So range is nothing but the values taken by a random variable. So I define a new random variable y, which is a function of a random variable x, which is 3x. So if I wanted to find what are the values taken by that y, is equals to 3 into 1 plus 3 into 2 into 3 into 3. And as I told you earlier, if this is a linear kind of function, what you will get? The similar probability distribution, right? You can check later on, but yeah, this should be looking like this. Okay. Now what is expectation of y? It is 3 into 0.2 plus 6 into 0.4 plus 9 into 0.4, right? So this is 0.6 plus 2.4 plus 3.6, 6.6. You can check,
Sir,
right?
is the major content for week 10 over?
No, one more topic is there, then I think it will be done. Okay, so if you want to leave, it's fine, because you can this anyway, this is live stream, so you can check it later, right? Okay, so after exactly 2 hours you can check this one. Okay, so this is okay, all of you are okay with this? So
Yes, sir.
this property is satisfied,
Yes, sir.
right?
Yes, sir.
What about property of variance? So what is variance of x? Did you find out earlier? We have found out somewhere. This, yeah, this is 0.56, right?
5.
So I'll write this as 0.56. So as per this property, what should be the variance of 3x? it should be
9 into 0.56.
So it is
5.04.
correct. Yeah, 1 meter.
Sir, are you there?
Yes, yes, 2 minutes. Give me 2 minutes. Okay, so yeah, what I have to do is I have to cross check with if this is correct or not. So this was my distribution, right? Distribution for y. Y is nothing but the function of random variable, which is 3x, right? What is the variance of in this case? So expectation of y square will be 9 into 0.2 plus 36 into 0.4 plus 81 into 0.4, right? So this is 1.8 plus, what is this? Can you tell me the value? I think this I just cross check whether it is correct or not. Um, I don't know, like
32.4.
32.4. Huh?
4.
Okay. Total. Okay. Fine. You are giving me the final answer, right? Right.
No, 81.0.4.
Okay. So can you tell me the final one? Final.
340.2.
Is it?
340.2.
I don't
340.
think so. No, no, I don't think it is that big.
No, no, sir, no, sir. 1 minute.
Okay, I'll calculate 36.
48.6, sir.
48. That is correct. Expectation of y square, right? Okay. So what is variance? Right. This is 48.6 minus 6.6 square. Can you tell me what is the value? Hmm?
5.04.
5.04. So this is variance of y. Is it correct now? This 5.04 and that we have just found out. This is the same thing. So these are the two properties. When I multiply with some constant, right? Expectation of a into x is a into expectation of x, and variance property is a square into variance of x. Okay. Similarly, if I wanted to add, what will happen? So let's say expectation of x plus. I don't see this will be the correct thing, right? Adding some constant, I'm not sure the property should be there because I okay. Is it there? I don't know. I don't remember all the properties,
Yes,
but
sir.
is it there?
Yes, sir.
Okay, let's okay fine. Okay, I think it is there. So yes, fine. This is important property anyway. Yeah. So adding the constant, what will happen?
Expectation of x plus a.
Plus a, right? And what is variance of x plus a?
Variance
This
is
is
same, sir.
variance
X
of x. That is it.
plus
No plus. So
yeah,
actually,
yeah,
see, so there is one property, one more property actually. It is there. So if you see, property is expectation of, let's say, x plus y is what? Expectation of x plus expectation
Expectation.
of y. This is true, I think, when x and y are, I think they are independent. Okay, so if they are independent, this property is hold true. I think in dependent case also it's true, but this property is not true when they are dependent. So this is only true when they are independent, right? So this is variance of x plus variance of y. So this is true in case of, I think, dependent and independent, both the cases. This is true only when x and y are independent. Independent, right? Okay, that is okay. So leave it. So this is the property, and I know what is very okay. What is expectation of any constant? It's constant, right?
So,
And
sir,
variance
here
is,
A is a constant, right?
yeah. So let's say I'll
But
take
the Y is
here.
another random variable.
No, A is a constant. I'm
What about Y, sir?
A is constant. Y is another random variable. X and Y are
Yes.
random variables. Okay. These two are different properties, and these two are different properties. Okay. So I'm just trying to correlate these properties. So when A is
Sir,
uh,
in this case of variance, x plus y is equal to variance of x and variance of y.
uh,
This is happen when x and y are independent
independent.
variables.
Yes,
Yes.
yes, yes. Right. Okay. So what is expectation of any constant?
Mean-
Is A. And what is
So
variance of
what
any
does it
constant?
mean, sir? Expectation of any constant.
Expectation of any constant means, like, yeah, if you have any, let's say if you have five, this is a data set. Okay, what is the mean value? 5, right? What is variance? 0. See, variance of any constant is 0. Variance of any sorry, expectation of any constant is that constant. So see, this is true for, see, x bar and this variance, right? They are associated with anyway expectation of that uh, random variable or anything, so, right? So expectation variance, the similar properties will hold true for mean, and so whatever mean and variance properties we have seen earlier, they are true for this expectation and variance of the random variable also. Okay, so expectation of any constant is constant. Okay, and variance of any constant is 0, where A is a constant. Okay, so let's say how this property comes. Expectation of x plus A. So I will use this one, this equation 1. So by this equation, I can write expectation of x plus A as expectation of x plus expectation of A, right? So expectation of x is expectation of x, expectation of A is A, right? From here. Okay, and this is I have written here. We can show that. I'll show through the example. Similarly, variance of x plus a is I can write this as variance of x plus variance of A, but variance of any constant is 0. So variance of x plus A is equals to variance of x, right? So I'll show you through the example. So our example was what? Again, I will take the similar example, which is what is it? X1, 2, 3. Probabilities that x equals to x is point 0.4, so sorry, 0.2, 0.4, and 0.4. expectation of x was equals to 2.2, and variance of x was what? Point? I think it is 4.5 or 4.56.
5.6 something.
Yeah, 5.6. Okay. So let's say I do this thing. I will define one function y as x plus 2. Okay. What is the range of y now?
3, 4, 5.
3,
4,
4, 5. What are the probabilities associated with y? 0.2, 0.4, and 0.4.
0.4.
Okay. Now, what is expectation of y? Or what? Okay. What expectation of y is nothing but what? Expectation of x plus 2, right?
Yeah.
So expectation of y is what? 3 into 0.2 from here, right? 3 into 0.2 plus 4 into 0.4 plus 5 into 0.4. So this is 0.6 plus 1.6 plus 2, which is nothing but
4.2.
4.2, sir.
4.2, right? 4.2. So if I use
Plus
my right, so if I use my uh, property expectation of x plus 2, so expectation of x plus 2 is nothing but expectation of x plus expectation of 2. I'll say this is equals to
2.
2, right?
Yeah.
So what is expectation of x? 2.2
2.2.
plus 2, which is nothing but
4.2.
done. What about variance? So you can check with
In
the
variance,
variance.
there is
Here
no
for
change.
3, 4, and 5, you have to take the same probability as set of 1, 2, and 3, sir.
Yeah. Actually, it is same because I think in this lecture itself I showed, right. I can find the probabilities from this, no, that I can find like this, right? Probability that y is equals to 3 means what? Probability that x plus 2 equals to 3, right? And then I can say probability that x equals to, that means 1, and probability that x equals to 1 is what? 0.2. I have showed that one, right?
0.2. Yeah, you have some.
Yeah, so this you can use that one, and I told you that if these are the linear functions, the probabilities won't change. So this is the linear function, right? X plus 2, and hence the probabilities won't change. Okay. Okay, done. So let's talk about variance now. What is the variance of this? So for finding out the variance of y, what I'll do? I'll find out expectation of y square. Expectation of y square is what? 3 square, right? 9 into 0.2 plus 4 square, 16 into zero point 0.4 plus 25 into 0.4. This correct? If this is my probability distribution, this is my expectation of y square. Is it fine?
Yes.
Hmm? What is the value? 7.2, 8.2, 9.
That is 10. 0.4 plus 10.
Right? This is okay?
Yes,
And
sir.
variance of y is expectation of y square minus expectation of y whole square, right? So this is 9.2 minus point, I think 4, no, 5.6 square. So can someone calculate this one? Am I correct or am I wrong here?
What's the answer?
Oh, sorry. I did mistake. Expectation of y is not 0.56, right? Expectation of y is this, right? Are you guys understanding what I'm trying to say?
Yes, sir.
Okay.
Continue, sir. We are understanding.
Krishna y square is 18.2.
I think I did some mistake because I'm not getting the answer.
Krishna y square.
It's 9 into 0.2, right? So 3 square into 0.2, which is
Minus
1.8.
9.44.
No, it shouldn't be like that, right? 1.8. Just check this calculations once. 16 into 0.4 is 6.4. This is correct. 25 into 0.4 is
10, sir. 10.
10, right?
I think it'll be 8.3, sir.
That is 10.
18.2.
Now tell me the values. 10 plus 6.4 plus 1.8, which is
18.2.
18.2. And yeah, that's why I did mistake, right? 18.2. Now tell me the values. Where was what happened? So yep, 4.2 square 0.6. What happened now? What is the effect of addition?
It
Unchanged,
will
right?
remain same, unchanged.
Right. So if you see, so this property is also verified. Okay, this property is also verified, right? Okay. So yeah, I think I wanted to show you one more trick, maybe, to calculate the probabilities of functions of random variable. So I will tell you that one. Let x will be equals to 1 3, provided that x equals to small x is,
Can you please scroll up just a minute?
yeah, okay, fine.
Okay, sir.
Okay, so I will tell you the probability, one more trick to find the probabilities of the function of random variable. So let's say this was my uh, probability distribution for x. Okay, so if I wanted to find probability that or maybe if I wanted to find, let's say if I define a new random variable y is x plus 2. So how to find the probability distribution for y? Okay, how to find it?
Yes, sir.
uh, First of all, find the range again. Okay, range is nothing but, yeah, is range of y is
3, 4, 5.
3.
3, 4 and 5. Okay. Okay, I think I no, I can't. I'm not sure. Okay, maybe we don't need to, while finding out the expectation of y, I don't need the probability distribution itself. So I how to find this? Expectation of y is equals to expectation of x plus 2, and okay, this is the property we have used. Yeah, this is a property we have used already. I think I wanted to show you something else, but I forgot what to do. Okay, fine, this one. So these are the properties, right? Expectation of y is equals to this, variance of y is equals to variance of x plus 2, which is nothing but variance of x. That's it. Okay, so about two different random variables, right? We wanted to see two. Do you have that property? I'm not sure whether it is there in your syllabus or not, these two properties. But yeah, I'll maybe you can, until this point is clear, right? I'm not sure. Okay, I'm not going to show you the proof for these two properties. This it is there, but maybe we can discuss it in some other session or something. So I'm not I haven't gone through the lectures this time, so I'm not sure whether it is there in your syllabus or not.
Okay, sir.
Okay, so this is it. I think this is fine, right, for today.
Yes, sir.
I think that is too much of content for one day.
Yes.
So, yeah, so I think I should
No,
leave
sir,
at
it's
this
okay.
point.
So actually, I have a small doubt regarding grade. Can I ask?
Yeah, please tell me.
Yeah, actually, how our CGP will be calculated? Like what's the contribution of a weekly graded assignment and Qs and end term examination in our CGP?
I think it is there in your grading policy, right? Grading document. Have you checked your grading document?
Yes, sir, it is there.
Hmm?
It is
So
already.
go to your course introduction on your portal.
Okay.
Course in that. Did you go into that?
Yeah, like I'm not getting a clear answer. Like
Yeah, okay, I'll
how?
tell you. So okay, just go to your course introduction first.
Okay.
Okay, I'll tell you. Maybe I'll show you. Is it my screen visible? No, right?
Yeah.
Okay, so is it visible now?
Yeah.
So I'll go to course introduction, then go to this general instructions and important links. Actually, your contribution towards the
Like
grades.
how our weekly graded assignment like contribute in our CGP?
This is 0.1. So 10% of your average actually. So if I go to statistics for data science 1, okay, did you understand where I went? So I went to this general instructions and important links.
Yeah.
Then here it is click here for the grading document, right? You just have to
Okay.
click on this, click here for the grading document. You'll get this grading document for each of the subject in this program, and then you have to click on your particular subject. So here I'll go to statistics for data science 1. So this is it. So you can see this T is the total score. Okay. So in
Okay.
that, what is 0.1 times GAA? What is GAA? It's average score in best 10 out of all the weekly graded assignments. So 10% weightage is there for your total score, and then this is max of 0.6 times interim exam plus 0.2 times maximum of quiz 1 or quiz 2. If this is maximum, then we'll use this formula. Otherwise, we'll use this formula: zero point 0.4 times the final plus 0.2 times quiz 1 plus point. Whichever is the greater thing, we'll use this plus 10% of grade assignments, and you'll have the total score.
And the syllabus for end term examination is week 1 to week 12. Yeah.
Yeah, week 1 to week 12, and more emphasis on week 9 to 12. So around 70% of the questions will be coming from week 9 to 12.
Okay, sir. Thank you, sir. And
Okay.
thank you for this wonderful lecture.
Okay. Okay. So
Thank you,
thank you
sir,
guys.
for today's lecture. Good night, sir.
Thank you, sir. Good night, sir.
Can I
Thanks,
ask
sir.
doubts now?
Which one?
Week 9, sir.
Yeah, tell me. Yeah. Yeah, are you there?
I will try it on my own, sir. If I don't get it, I'll ask.
Okay, fine, sure. Okay, then let's close the session now, right? Okay, guys, bye.
Okay, bye, sir.
Good night, sir.
Good night.
Thank you, sir.